Here we'll do a little bit more investigation about the bell curve. Let's first begin by drawing a bell curve. The highest point on this curve is called the mean, or average. Let's calculate the mean in Excel now. I'll type a label in column C, and in column D, we'll use the built-in Excel formula to find the mean. We'll say equals average, open the parentheses, and select our list. Close the parentheses, and we have a mean of 76.875. Once again, I'll go to the number menu and click the decrease decimal button on the right until I have only one decimal place. So our mean will be 76.9. At this point, you may encounter another concept called z-score. For any value in our list, the z-score is how many standard deviations away from the mean that value is. So we could say that our mean automatically has a z-score of 0. However, oftentimes on a bell curve, you'll mark down the points that are 1, 2, or even 3 standard deviations away from the mean. For example, we could mark down a point on the graph that is 1 standard deviation away from the mean. We'll mark this with a z-score of 1. To find the value, let's click in an open cell and take the mean plus a standard deviation. So we'll say equals. We'll click the 76.9 for our mean and add the standard deviation, 11.5, giving us a value of 88.4 at this marker. We could repeat this process for a standard deviation of 2 if we wish. We'll draw another marker, place a 2 as the z-score, and then we can do this calculation again. We can say equals the previous number, 88.4, and then add an additional standard deviation, giving us a value at this marker of 99.9. Notice it's slightly out of alignment, so to shift it to the left, I'll go to Home and click this button on the left side to force it to align to the left so it's underneath the line a little nicer. It is also possible to have a negative z-score. We can make an additional marker to the left of the mean. We'll mark this z-score as -1. Negative z-scores will always be on the left. Positive z-scores will always be on the right. To calculate this, we can take the mean and subtract the standard deviation instead. We can say equals, click the mean, minus the standard deviation. And we get a value of 65.3. We can also mark another point further along, give it a z-score of -2, and then take away another standard deviation. We'll say equals the previous number and then subtract an additional standard deviation. And this marker will be 53.8. One final point. We know our minimum value is 50, and so we would cut this graph off at 50. We know that none of our scores go below there. For the values on the right side, we know that the highest we can go is 100, and we would cut the graph off at 100. Now at this point, you may also encounter something called the empirical rule. The empirical rule has to do with the percentages of the population that we would predict are between each of these markers. in a standard normal distribution. Now, the empirical rule says if the distribution is normal, in between the 0 and 1 markers, you would find 34% of the population. So we could predict that 34% of the population would have a score between 76.9 and 88.4 on this quiz. For the same reason, between -1 and 0, we would have the same population. As in a standard normal distribution, the data should be symmetric. Now, in between 88.4 and 99.9, that is, between z-scores 1 and 2, what we expect is to find 16.5% of the population. For the same reason, between -2 and -1, we would have 16.5% as well. Now, past a z-score of 2, we would expect to find 2.5% of the data. And lower than 53.8, we would also expect to find 2.5% of the data. Now, because of this limiting value of 100, our distribution in this case would not be perfectly normal, because this tail on the right would be cut off, because it's not possible to have a score greater than 100. So there wouldn't be very much data on this tail unless you made a perfect score. However, we can still use the empirical rule to approximate what percentages we would expect. It wouldn't be exactly right, but we could expect it to be fairly close.